Okay, we're going to finish off these problems after you've had a chance to try them. So to find the y-intercept, who can remind me, what do I need to do to find the y-intercept? I need to set x equal to 0. Now I can FOIL this out, or I could just plug in f of 0. f of 0 equals 2 times 0 minus 1, 0 minus 3. That gives me negative 1 times negative 3, which is 3. So 0, 3. Did everybody get that? That's the y-intercept. Does that make sense? You probably did it a different way. You FOILed it out. That's okay. You should get the same thing. There's lots of different ways, you know, to do these things. Okay, so this was my y-intercept. I don't know why I changed colors. I wanted to change colors for my x-intercept. How do I find my x-intercepts? And you see how it has a parenthesis 0, or I mean s, not 0, s, because it could have more than one. We were just talking about how with a parabola you could have 2 x-intercepts, 1 x-intercept, or no x-intercepts. We were talking about that in class a little bit, okay? Those are 3 different options. So any ideas on what do I do to find the x-intercepts? What do I do? Set y equal to 0. F of x is the same thing as y. So we go 0 equals 2x minus 1, x minus 3. Now some of you went on a loop, you FOILed it, and then you refactored it. That's okay. They gave it to you in factored form. So what do? We set each factor equal to 0 and we solve for x. Now the reason why I set, a lot of times we just do this mentally, but it's a little bit harder when you have a 2 as a coefficient here. So we're going to add 1. We get 2x equals 1, divide by 2, divide by 2. Okay, here, this equals 0. Add 3, add 3. We get x equals 3. So we should have, we're putting them in as ordered pairs. So, what number is that? 1/2, 0. 3, 0. Is that what you got for the x-intercepts? Oh, I was wondering why that didn't actually... Why did you guys get... I thought you guys got negative 1/2. Oh. But did I do it right? Okay. Let's talk about the axis of symmetry. That's the first thing we're going to find. X equals negative b over 2a. We have to use that formula. So what is b and a? Okay, and by the way, I have to actually, I currently do not have this in the right form, right? So you have to FOIL this out. In order to find a and b, you need to FOIL this out. So we would get 2x squared, that's negative 6, negative 1, negative 7x plus 3. Oh, look, there's that same plus 3, positive 3, right? So negative b over 2a is going to be negative 7 over 2 times 2. Does everybody see where we're getting this? 7/4. So x equals 7/4. X equals 7/4. A lot of you got that and you were like, that can't be right. But you guys, there can be fractions. Fractions can exist, okay? So 7/4 is our x. How do we actually find our y? We know, a lot of you already said that 7/4 is the x coordinate of the vertex. How do we find the y coordinate? Yes, we're going to go f of 7/4. We're going to plug in 2 times 7/4 minus 1 times 7/4 minus 3. Okay, I don't want to work that out either, so I'll just take my calculator and I'll plug in 2 times 7 divided by 4 minus 1, close parentheses, and another parentheses, 7 divided by 4 is the fraction, 7/4 minus 3. Okay, and we get negative 3.125 is our, oh, that was our y value. I get it, why we're coming up with different things here. Okay, so now that's our y coordinate. Is that what you got for y when you plugged it in? Did I do it right? That's the right answer? Okay, so now let's just sketch a graph of what this would look like. Of course, you can use your calculator. In fact, maybe let's use our calculator also to help us visualize it. Okay, so let's just plug in. If you foiled it, you can also plug in your foiled version. And if you factored it, I mean, it's already factored, so you can plug in the factored. Either way, 2x minus 1 parentheses x minus 3 close parentheses graph. Okay, we're going to see a parabola emerge here. And it looks like that x-intercept is 1/2. The other x-intercept is 3. Does that look reasonable that that's crossing the y-axis at 0, 3? That looks reasonable to me too. And then if we want, we can find, now if I go second calculate, I want to find the vertex. Which one of these do you think would give me the vertex on this parabola? Minimum, right? Minimum, because it's the smallest value. The left bound, is my cursor on the left side of the vertex? The vertex will be here. Yes, enter. Scroll to the right. Am I on the right side of the vertex? Yes, enter. Guess, enter. And we get 1.75 and negative 3.125. 1.75 is probably the same thing as 7/4. Do you believe me? If we go 7 divided by 4, 1.75. So it's going to give you, on the graph itself, it gave you the vertex as a decimal instead of as a fraction. Fractions, decimals, they're equivalent. So I don't really care which one you use. Usually we like to use the fraction in simplest form just because some fractions are repeating decimals, and then you get into the trouble of it's not exact, you have to round it off. Okay, any questions on that one? Don't let the fractions throw you off. Just let the calculator help you if you're having a struggle doing all that math. Okay, let's do the next one, y-intercept. Can you tell right away just from looking what the y-intercept is? What is it? It's 0, 8. So you said 8 and I said no, because remember, it needs to be in XY form. That's very important. It says that on the, like, these are things that are like people take for granted on a test, especially in Math 95. If you just write 8, I will take off 1 point. Why? Because it says in the directions I need it as an ordered pair. Okay, 8 is like, what is 8? $8? 8 years? I don't know what 8 is, but 0, 8 as an ordered pair, I know where that is located on the graph. Okay, I'm going to skip the x-intercepts for a moment. Well, no, let's just do the x-intercepts. How do I find the x-intercept? Y equals 0, right? So I go 0 equals x squared minus 4x plus 8. Some of you noticed, what did you notice about this one? Oh, because next you would factor. It's not factorable. Okay, so let's just hold on to this for a minute. We don't know what's going on with it just yet. Can we find the vertex? Okay, what do we do to find the vertex? Okay, so you start with x equals negative b over 2a. You start with the axis of symmetry. X equals negative 4 over 2. 2 times 1. Sure, you put that in. Okay, x equals 4 over 2, which is 2. So the axis of symmetry is x equals 2. How do we find the vertex after that? F of, yes, substitute the x, so we get 2 squared minus 4 times 2 plus 8. This is 4 minus 8 plus 8 is 4. So the vertex is 0, 4. Now let's draw a little sketch of what we have so far, because the thing is that you guys are saying, hey, I don't know what the x-intercepts are. I want to tell you that there are, again, 3 different options. What's that? Sorry? Oh, you're right. 2 and 4. Oh my gosh. Ah! You guys, I make mistakes sometimes too. Okay, good. I'm so glad. I'm so glad I made mistakes so that you could catch my mistakes. Yes, you can learn that it's not just you, it's me too, okay? So I'm going to draw a picture of what I have so far. So 1, 2, 3, 4, 5, 6, 7, 8. 0, 8. Plot it, label it. That's the y-intercept, okay? Y-intercept, why? Because it happens on the y-axis. We know the axis of symmetry is 1, 2. X equals 2 is this line. X equals 2. Can you see this? Okay, I'm just drawing a sketch of what I have so far. Where's the vertex? 2, 4. 1, 2, 3, 4. The vertex is here. This is the lowest point. How do I know that this is the smallest point? Yeah, so it's coming down here, and then it's going to curve around. Can anyone tell me what is a point on the other side? The symmetry is 2. So this is 1, 2 units away. There's another point 2 units away. So what's this coordinates of this point? Ah, x is 4, y is 8. Is it ever going to cross the x-axis? So what are the x-intercepts? There's no x-intercepts, none. Because we can see, and then of course I would take it a step further if I were, especially if I were you, I was at home and I found this confusing. And this question is going to come up on Connect Math as well. They said, okay, they gave you you found the axis of symmetry, okay, and then they'll say 0, comma, and blank blank. Give 2 symmetrical points. So if you have the axis of symmetry and you know what the vertex is, you can find those other 2 points, because 0, 8 is the y-intercept, and then I would suggest sketching it out just like I'm doing. Okay, and then 4, 8 is the other one. So you'll see those coming up on Connect Math as well. Those are 2 symmetrical points around the vertex and axis of symmetry. Does that make sense? Okay, and then again, you can also just graph it. Just go to your graphing calculator, plug in y equals, plug in, oh, clear it out, x squared minus 4x plus 8. It's not that I'm saying, you know, some of you are uncomfortable with this because you're saying, well, I want to know how to do it by hand, and that's great. I'm just saying use the technology to help you understand it, to further your understanding. Don't become dependent on the calculator, but just use it to support what you already know. So you already know what it should look like, and you already think, hey, it possibly doesn't have any x-intercepts, so just graph it and see, okay? Any other last questions before we conclude this video? Oh. Yes, so again, if I wanted to find the vertex, I could go second calculate. Which would it be, minimum or maximum? Minimum. Because it's at the bottom of the parabola, it's the smallest point. Am I on the left side of the minimum? Yes. I scroll to the right, scroll using my little arrow button, scrolling to the right. Am I on the right side of the minimum? Yes. Guess. You push enter one more time. There's the minimum point, 2, 4, and that's the same thing we got for the vertex here, 2, 4. Okay. Any last questions before we conclude this very last video of Math 65? We got the idea of the basic shapes of a parabola, and essentially what you kind of notice is happening is basically this is the parent function. We call this, this is the basic parabola, basic shape of a quadratic. What is happening then? We're adding and subtracting things to this number, and it's changing the positioning. If we change the coefficient a, we're going to increase or decrease the shape. So another good activity could be to go on Desmos or even go on your graphing calculator and just play around with, okay, well, what happens if I have 2x squared? How does that change the shape of the graph? Oh, it's a skinnier parabola. What would happen if I had y equals negative 2, or no, 1/2 x squared? And what's nice about this color screen calculator is that you can see the different, you can tell the difference, okay? But you will graph them one at a time. Oh, if the coefficient is 1/2, it's going to slow down the growth. It's going to take half. But remember that the most basic way of always graphing is just creating a table of values. And you can do that all day, any day. With any kind of equation, you can always plug in x values, come up with y values, come up with an infinite list of ordered pairs and plot it, right? Because the whole reason why that these are solid lines is because there's no spaces in between. It's not just whole integers. We love integers, but it's not just whole integers that we can graph. We can also graph fractions, right? And still get y values. They're still on the graph. It's just that to make it more convenient for ourselves, because we like integers, that's what we usually use in a table of values. So what I would encourage you to do is play around with these, experiment, get lots and lots and lots of practice, and then send me what questions you have that you want to go over, okay?